Okay, so again, because I forget to record, so I will repeat the definition again. Okay, so I think like this cell, we have around 20 or 30 students will attend more. This classroom not enough for 100. Okay, so again, what's the pattern recognition? As we said, pattern recognition, it's a study of how to make machine observe the environment, identify the patterns, identify the objects, okay, and classify it in some classes or some categories. And what's the pattern itself? Anything around us. Could be an identity or entity, like a human, like animals, like trees, like so on. Could be some fingerprint images or medical images or any text, handwriting, sound. So almost anything that the human can recognize, we want to try to make this machine clever enough to also recognize it. Okay, so this recognition, it's done by classify or categorize the patterns into categories or into sets by some common attributes or features. Like if this object tall or short, like if this object color brown or blue or white, or okay, the colors, the area of the object, the shape of the object, its rectangle, its triangle, and its circle, and so on. All these attributes or features for the patterns or for the objects. So the machine will classify or categorize this object by the similarity of these attributes or features. Okay, we have many examples. For example, this was very difficult before 20 or 30 years. It was very difficult for the machine to read the handwriting like this handwriting. But the recognition, it's easy to recognize this handwriting into machine form, so into text in the machine and transmit it. This OCR usually, yes. Another example from Chinese handwriting, also for some, let's say, fingerprinting, eyes, of the eyes, and so on. Recognition, it's some for preference for fingerprint. All these types of pattern recognition, the biometric systems to recognize a person from his face, from his iris of the eyes, from fingerprinting, from the sound, from the hand, okay, from the signature to what? It's very difficult one. We call it key story. From the way of type in the computer or in the keyboard. You know, it's like the fingerprint. Each one have different way for writing on the computer or in the keyboard. Of course, face, even tooth and so on. In the medical field, it's commonly used, okay, the pattern recognition. For example, here, cancer detection. Students who did their master thesis about cancer detection, about and one about Alzheimer, early detection, and so on. From what we can recognize this, it's like the normal doctor cancer usually detect cancer from MR image or from X-ray for some other field, for diabetes from maybe from the eyes, can detect it from the blood, from many things. Also, we can teach the machine to recognize these patterns for disease. I give some labeled pictures or labeled data and teach the machine. Okay, this same issue for cancer detection. Of course, things like this, if it's have image, it's need also image processing and before the pattern recognition. We will take or we will speak about these steps. I think, how many of you already took the machine learning course? Oh, not too many. Okay, so others did not take machine learning, so it will be more interesting, this course. In the machine learning, you apply the algorithm or you try to calculate like the algorithm, go deeply in the algorithm? Yes, I guess that. So I told you, pattern recognition, it's like learn programming, and machine learning course, it's like being a developer. Yes, only use the tools. But pattern recognition, we need from you to know how it's work deeply, and if you would like to program algorithm, you must know how it's work. Okay. For land cover classification, also it's commonly used. We have one of our colleagues from GIS field. This his work. Usually he works like this. Okay. So in land cover, we try from the satellite image to make the computer recognize the objects in the maps. Okay, like this building, this, for example, grass, this trees, and so on. This is another example. This, you can see it always on the door of the university, the out gate, yes, which is recognize the plate of the cars, yes. Okay, so for better recognition, how can the machine learn from the data to recognize the pattern. We have three types of learning: supervised learning, unsupervised learning, and reinforcement learning. I always call reinforcement learning, it's the kids learning, yes? Same way of teaching the kids. This is a reinforcement learning. Okay. What's the supervised? Supervised means now you have supervised learning. Why? I'm the teacher, give you some information. Yes? So this supervised learning. In the supervised learning, we have teacher to teach this machine. What's a teacher? Teacher, it's maybe person or something that have data, this data already categorized, classified, depending on some features, and have label that this class with this feature, it's cats. This class with this feature is or are dogs. And this horses, this debate. So we give some examples that already labeled and we have data about its feature for the machine. Then the machine after that can classify the new data depend on or new objects depend on this feature of the new objects. It's a clause for which category mode. You imagine what I said, it's a clause for which category, because we speak about similarity here. It's not identical, same feature, 100%. So how it's work actually? It's work like this. We have the data, okay, as points. So we have this class, and each class have some objects, and this is a feature. You can imagine 2-dimension, but it could be 3-dimension, 4-dimension. Each dimension means a feature, yes? Then, when the feature in a specific point, we have this object in this category. So if we have a new object, depend on the distance for the feature will be classified into specific category. Okay. Okay. The other type, which is unsupervised learning. We will return by examples for each one next lecture. Okay, unsupervised learning, we don't teach the system. We don't teach the machine. We tell the machine that we have this objects, and this object will be clustered. Clustered means it will be categorized into a group by the machine. How it's categorized? Based on some similarities in criteria. So it's like we don't have labels. The machine will generate the labels. So we have some objects. Okay, some objects. And the machine will categorize, will cluster objects without teaching the machine. How it's work? Its work depends on the similarities of some criteria, some features. So we don't say, okay, this class and this another class, then the new one will be in this class or in this class. No. The machine here, if we said we have some criteria for this feature, could they classify or categorize, cluster this as a group, this as another group, this as another group. Different criteria could make the machine classify this as a group, this as another group, this as another group. One of the criteria also how many clusters we have. We could tell the machine that we need 2 clusters, 3 clusters, 4 clusters. Okay, what's the difference between this and the supervised learning? I will give you example. Okay, for example, in supervised learning, the aim also different between supervised and unsupervised learning. In the supervised learning, we teach the machine by some previous examples. For example, we give some picture, some MRI pictures or photos for the cancer disease, and we identify the feature for the machine. Then, after we teach the machine, now it's have something called a classifier. Okay. Next time, if we have a new MR image, we give it to the machine. The machine will extract the feature from the image. Depend on the similarity, it will classify it in some category. Categories that we already mentioned for the machine about this category. Okay. For clustering unsupervised learning, we give the data and our aim not to classify the future objects. No, our aim is to ask this machine to classify this data. For example, okay, we have the selling data in one of the website. Okay, what this website sold in some countries, and we ask the machine to classify, cluster, categorize, let's say. The country depends on the range of how much from this country buy from the level of, okay, I need to categorize it into 3 categories: high, low, and medium. Okay, so it will categorize country X, Y, Z, it's low. Country X, K, L, M into the median, to the high. Then, after the machine categorize for me, then I can make a plan for the advertisement. Okay, those countries, it's in the low category of buying from my website, so I will make more advertising here and so on. So the aim here, it's to make the machine class and categorize the objects depend on some features. But in the classifier, no, I teach, I learn the machine, and in the future, I will ask the machine to classify some object in one of the groups that I identified for the machine previously. Okay. About reinforcement learning. Reinforcement learning, it's like teaching the kids. How the mother and the father teach their kids. Okay, the kid's doing something. You will say, okay, great, give some praise or reward him for doing some good things. If he did some incorrect or bad things, maybe you can speak with him, give him some feedback. It's wrong to do this, and so on. So you give feedback about the way of or the behavior of these kids. Same issue here. Reinforcement learning, we don't need to make any category, okay? for the system or the machine feedback when it's take decision, that this decision is correct or not correct, and the machine will learn the right and wrong things from this feedback. It's good for some applications like robots, okay? For robots, if the robots will move in new environments or do something in a new environments, okay, the reinforcement learning here could help for teaching this robot for doing the things next time correctly if it's not correct. One of the application, for example, one of my students, not a friend, okay, did his master research in, you know, the Dino game for Chrome when you don't have internet, okay, how to make it play itself. So he used reinforcement learning, one of the reinforcement learning algorithm, to give praise for the machine if it's do it correctly, feedback if it's not correctly, and so on, until teach the machine using this reinforcement learning until it can do or play this gaming or this game without human. Okay, so this is some applications for reinforcement learning. About our course, this is the topics during this semester. Okay, before that mention the topics,